So the thing the connection that we need to make today, all right, is about one sample t-test still. Hopefully you feel pretty good about those after the last lesson and the video. But there's a connection here between a two-sided test, so not a two-sample, but a two-sided test and a confidence interval that I want us to see. There's a real strong connection between those two. We're going to look at that here today. Once we've got that down, then we are going to talk about the topic we all know and love to hate, errors. All right, type 1 and type 2 errors. Those have not gone away. And so we gotta talk about them again to get a bit of a refresher for how those work. Your video, I know, right? Your video will be about 2 sample t-tests, okay? And that pretty much rounds out the unit, okay? Once we get all the 2 sample t-test stuff done, that's it. So the rest of this, I guess, not quarter, because quarter ends Friday, but the rest of this before spring break, we've got our lesson on Thursday, then video lesson probably over the weekend to really finish things off if we don't get it all done. Tuesday will be our review day. Thursday will be our exam. Okay? Tuesday review next week, Thursday exam, and then we got spring break. We can make it, ladies and gentlemen. We can make it. All right. First, before we get started, though, there were a few things I wanted to say about the quiz. Okay? For the most part, we did really well on that. If you haven't looked at your grade yet, a lot of the scores were really good. There were a few things that I wanted to say because the question was an experiment and not a random sample. Michelle, correct. It won't make it to the third quarter grades. It will not. No. All right, couple of things about the quiz here. First, because it was an experiment, there is no SRS. There's no random sampling. It's not a random sample. We have random assignment instead. Okay? I didn't take points off. No, this one I think I was. This one was the more important one that I wanted to see. You needed to mention it was random assignment, not a simple random sample. We don't have independent random samples in this case. Okay? We have random assignment instead. Then the other thing, because it's an experiment, there is no 10% condition with experiments. Because we're not sampling anything, we don't have to worry about sampling with or without replacement, so we do not need the 10% condition. I didn't take off any points if you had the 10% condition there, but there is no 10% condition for experiments. That was a common thing. And last but not least, the last question. So with your interval, you should have seen that, 0 is in the interval. Okay? And that means no difference is a plausible possibility. A lot of us did get that, but I was seeing fairly often, a lot of us would imply that it was the only possibility. 0's in the interval, so there can't be any difference. They're exactly the same. We can't be that absolute about it. Only the Sith deal in absolutes, ladies and gentlemen. All right? And you're not evil. Not yet, at least. You're too young. All right? If 0 is in the interval, there being no difference is a plausible possibility. We still believe that there might not be any difference. Okay, we don't have convincing evidence that one is bigger than the other. And some of us were just being a little too strong in our language, that saying that there was no difference. It's just still one of the possibilities in that case, okay? So you got to be careful there about when you're talking about intervals. We don't know anything specific. We just know the interval. What are the possible values? All right, the ones that are still plausible at that confidence level. All right, I think those are the only 3 things I wanted to say there. Yep, about the quiz. There is a version 2, so if you do want to retake that and get a better score, stop on by office hours. You might even be able to twist my arm and get me to grade it and put it in before Friday, Monday, if you stick around. All right. That's all I want to say about that. Time for the new stuff, all right? 2-sided tests and confidence intervals. There's a connection here that I want you to see, all right? So if you want to screenshot this or take a picture of it, this is the connection. If a 95% confidence interval captures the null hypothesis, then we will fail to reject the null if we ran the test at a 0.05 level. Okay, building off what I had just said, if the 95% confidence interval captures the null, then the null is a plausible possibility still. And if it's a plausible possibility, we wouldn't reject it. I hope that logic makes sense. If the 95% confidence interval captures the null, then we would fail to reject the null if we did a significance test instead at the alpha 0.05 level. And then the flip side of that, same relationship but backwards. If the null is outside the 95% confidence interval. So if it's outside the confidence interval, then we would reject the null at the 0.05 level. Because if it's outside the confidence interval, it is not a plausible possibility. And if it's not a plausible possibility, well then, I hope we would reject it, right? We would reject the null then. So that's the basic idea, okay? We're going to do a couple examples here to show you that in practice, but I'm hoping I can make those 2 concepts make sense here with these examples, okay? All right. Hopefully you've screenshotted that or written it down or something. Otherwise, I will push this out into your OneNote. All right. So a month before the shutdown, Mr. Bolt dropped like $400 on 4 season passes to the Monterey Bay Aquarium, and I didn't get to use them once. I'm not bitter. No, not at all. Ugh. Timing, man. Oh well, it's a good cause, right? It's a good cause. I'm all for supporting the aquarium. It's an amazing place. But we're like, yeah, we'd definitely come here a couple of times over summer. That'd be awesome. It's not that far of a drive. We found an awesome park near it and everything. And then, yeah, well, we know what happened. Too bad. So, aquariums must make sure the water temperatures for the fish are very precise. If the water is too hot or too cold, the fish can get sick and die. All right, so got to make sure the temperature's right. One tank at the Monterey Bay Aquarium is set to be 45 degrees Fahrenheit. Yes, I made that up. We take temperature readings at 40 random times during a day to test whether there is convincing evidence that the average temperature is not 45 degrees. Our sample of 40 temperatures gives us a x-bar of 46 and a standard deviation of 3.5. So I'm hoping it makes sense that there's kind of two ways we could go about this question. We could do a significance test with a null and alternative hypothesis, or we could do a confidence interval. And they would kind of give us the same information to make this judgment, whether or not the true average is 45 degrees. So we're going to kind of do both of those side by side right now. All right, on the left, we'll do a significance test. On the right, we'll do a confidence interval. And I'm hoping you'll see that they give us the same information, that there is a connection here. So on the left, our significance test, we will test at the alpha 0.05 level. So our null is that the true average temperature, mu, is equal to 45 degrees. Our alternative hypothesis is that the average is not 45 degrees Celsius. It's something else. All right, this is a two-tailed test because larger numbers give us evidence against the mean, against the null, but also lower numbers give us evidence against the mean. So those two extremes will both give us evidence against the null to reject it. On the other side, we're going to do a similar thing. We're going to do a 95% confidence interval for the true average. Where could the true average be based off our sample? So the mu's here are all the same. They're the true average temperature of the fish tank. Okay? I don't want to do the whole plan, state, do, conclude thing right now. That would take too long for us to see this relationship. But I'm pretty sure all the necessary requirements for inference have been met here. So in both of these scenarios, technically the math that's happening, what we start with is the sampling distribution, right? And in the center of our sampling distribution over on this side is the null hypothesis, which is 45. And then samples that are much, much bigger than this, samples that are much, much smaller than this, will both give us evidence against the null hypothesis, the 45. All right. Now, how big are those tails? Well, they're connected to alpha, 5%. If we have a sample in the rarest 5%, that will give us evidence against our null. That is actually the probability of a type 1 error, as a little side note there. But these two tails, right here, both of these together, are equal to 5%, okay? Or our alpha. Well, if they're both equal to 5%, oh no, sorry, if they total 5%, that means this one is 2.5%, and this one over here is also 2.5%, which means how much is in the middle? 95%. So I'm hoping that right there helps you see the connection between this and that. Okay, 95% in the middle, 2.5 on either ends. Those two 2.5s make the 5% alpha. There's a 5% chance of getting a sample that far away on our test. Okay, so, well, let's run our test now. All right, where is our sample? Is our sample in the middle? Is it somewhere over here inside the 95%? Or is it somewhere in here or over here in those very rare tails that would give us evidence against the null? All right, we find our p-value and we see if it's bigger or smaller than alpha. That hopefully is a bit of autopilot for us. So exit, exit, exit. I'm going to go, I want a test, right? So test, I want a t-test. I want a one sample t-test. And I think I've got everything typed in here, but let me double check. So our null and alternative. This one is our alternative that it's not equal to the null. Haven't done one of these in a while, have we? That it's not equal to the null. Our null is 45. The sample was 46 for the sample x bar average. And our standard deviation was 3.5. And our n, our sample size, was 40. All right, again, even if you don't remember those numbers, they just came from here, right? That was all in the problem. So we type it all in, and we get our p-value. Our p-value is 0.078. We compare that to our alpha of 0.05, which, bigger than alpha, right? Which means we fail to reject. All right, because our p-value is greater than alpha. So that means our sample average of 46 is somewhere over here. All right, it's inside the 95% confidence interval. It is not outside the 95% confidence interval. Well, let's double check that. Is it actually inside our 95% confidence interval? We should do one and see. So let's check our 95% confidence interval. So remember a confidence interval is going to be centered on 46. We're going to add, we're going to subtract to get our two boundaries. And we want to know, hey, is 45 in here somewhere? Is 45 a plausible value inside the confidence interval? Well, let's see. Bring up my calculator again. Exit. Interval this time. T interval. One sample. I want a 95% confidence interval. I want a 46 for X bar. Yep. 3.5 for the standard deviation and 40 for my sample size. And so my confidence interval is 44.9, 44.88 up to 47.12. So, in that range, is the null in that range? Most definitely is, isn't it? Somewhere over here. So 45 is a plausible true average, mu. And so I want you to see how those two statements are connected. They're saying the same thing. So why not 46? So 46 is also a plausible value. Okay? 46 is still definitely a plausible value. I want you to see the connection between the hypothesis test and the confidence interval. Okay? So with our hypothesis test, our original hypothesis was 45. That was our original belief. Okay? And so to test that, I want you to see that to test this hypothesis, yes, the hypothesis test will test it for you, but so would a 95% confidence interval. Does that kind of make sense? Now, I think here's what I'm wondering, if this is what's weird. If you were just going to do a 95% confidence interval, would the 45 ever even enter into the conversation? No, right? Because you wouldn't have a hypothesis. So if we were just doing the right-hand side, the 45 would never even be part of the conversation. So this is really only valid if you have a hypothesis to begin with. Maybe that threw me off a little bit sometimes. Because like, yeah, if you just did the right, where did the... Oh, yeah, I went over that pretty quickly. So that came from the problem. So in order to do any of this, we have to take our sample. So we take a sample, and of course, sample variability. We don't get exactly 45, right? It's never going to be exact. It's a sample. So our sample average was 46. So we took 40 temperatures. You know, some were high, some were low, some were high, some were low. And the average of the sample was 46, with a standard deviation of 3.5. So that gave us some evidence that the average wasn't 45, right? We have some evidence that it's not 45. So we test it. We run the hypothesis test. Is it 45 or is it not 45? But the idea is that significance test is kind of the same as a 95% confidence interval. Does that help? A little bit maybe.
Mr. Bolt,
Go for it.
so the 46 is only like based on the one sample that we have.
Correct.
It's not like, oh, okay. I was thinking it was more of a general thing than just the one sample. So I was getting confused.
It's all good. Yeah, the 46 is just, maybe I'll label it here. The 46 is just the X bar. It's the sample average.
Okay, got it. Thank you.
Mm-hmm. All right, let's do one more a little bit faster, without the graphs, without the pictures, and I think that will help line things up as well, okay? If you're still a little iffy with me. Let's do one a little bit faster, and I think that will help cement things in. So at the Hawaii Pineapple Company, I really hope that's a real thing. The mean weight of the pineapples harvested from one large field was 31 ounces. A different irrigation system was installed in this field after the growing season. Managers wonder if this change will affect the mean weight of future pineapples in the field. To find out, they select and weigh a random sample of 50 pineapples from this year's crop. All right. State an appropriate hypothesis for a significance test, and then define your parameter. All right, so what is our hypothesis test here? Our null is that the average is the same as it's always been. So last year it was 31 ounces. So our null is that nothing has changed. Our alternative is that it has changed. And in this case, they are just looking for a change, bigger or smaller. Okay, so because it's a bigger or smaller, it's a two-tail test, which means we want to know if it's simply not equal to 31 now. So, two ways we can kind of think about this now. Yes, we could run the test, find a p-value, if we had enough information, find the p-value and then either reject or fail to reject. But we could also think of this in terms of a confidence interval. If 31 is a plausible value, it will be in the confidence interval. So, a 95% confidence interval for the mean weight of all pineapples grown in the field this year is 31.2 to 32.6. Based on this interval, what conclusion would you make for a test of the hypothesis in part A at the 0.05 significance level? So is 31 in the interval? And we look, and it's not. All right, it goes down to 31.2. So 31 is outside the interval. It's outside the 95% confidence level. Interval, I guess. So we would reject the null at the alpha 5% level. It's outside the interval. It's not a plausible value at the 95% confidence level or at the alpha 5% level. It's not a plausible value. So our test would have rejected it if we could run it, but they don't give us enough information to run it. All right. How do you feel about that? Did that make some sense? Any other questions come up like, Bolt, where'd you get that answer? Throw me some questions if you got them. There might be one question I hope you have. I don't know whether to prep you for this or let you struggle with it on the... No, all right, we'll talk real quick. Before I send you to the practice. See that connection right there? That's not the only option, right? That's not the only option. A 95% confidence interval is connected with the alpha 0.05 level. Well, what about the other ones? What about a I don't know, a 99% confidence interval. What alpha would that go with? What about a 90% confidence interval? What alpha would that go with? I mean, you could do any of them here, right? 99.7 even. What alpha would that go with? Hopefully, that's not too hard to see. I guess we don't write alpha as a percent, do we? My bad. What would that one be then? 0.003? Does that kind of make, I'm hoping that relationship there makes some sense. I'm hoping those numbers aren't coming out from nowhere. Let's see, where is our, here we go, period 5. All right, let's see if this is connecting for you. Try these out. Give you a couple minutes there. Just the first 2 slides. Just the first 2 slides. That I want you to be able to see, okay? Between the confidence interval and the two-tail hypothesis test. Next, we got some time. We got to practice some type 1 and type 2 errors, okay? So I want to tell you a little bit about this real quick, and then we'll practice some before we head on out. If you weren't at the last study group right before the test, I came up with a decent way of remembering which one is which, if you remember. Which one is a type 1 and which one is a type 2. Okay? So a type 1 error is if the first hypothesis is true. All right, so that's the null. But I'm using the word first because type 1, the first hypothesis is true, but we screw it up. It's an error, right? A type 2 error, you might see where this is going. The second hypothesis, which is the alternative, right? But I'm using second because it's a type 2 error. That is the alternative hypothesis, is true. But we screw it up. That's how I'm keeping them straight in my mind. Now, you do need to be able to interpret then, what does it mean to screw it up? But hopefully that's a logical progression that you can come up with once you remember which one is which. Okay? If the first one is true, all right, that is the null hypothesis. If the null is true, well, then you shouldn't reject, right? It's true. You shouldn't reject. So that means screwing it up would be rejecting it. That would be an error. And for the next one, if the second one is true, if the alternative is true, then we should reject, right? Our conclusion should be we reject the null if the second one is in fact true. But the error would be not rejecting then, okay? The error would be not rejecting. Let's do a quick example of this, and then you can try the ones I've got in the Desmos to see if this is making some sense. It is difficult. All right, so back to our aquarium problem with the 45 degrees. So we failed to reject the null in that question. So here's the actual full conclusion. We failed to reject the null because our p-value of 0.078 is greater than our alpha. We do not have convincing evidence that the true mean temperature of the tank is different from 45 degrees. So remember, our null hypothesis was that the mean was 45, and our alternative is that the mean is not 45. What error could we have made? So let's say that this was an error, that this was actually wrong. Well, if our conclusion was we do not have convincing evidence that the true temperature of the tank is different from 45, well, that would be wrong if the temperature was different than 45. Well, that means this one is true. But we screwed it up. We didn't reject, even though we should have. That means this one is true. Well, if the second one is true and we screwed it up, that is a type 2 error. The temperature was different than 45 degrees. So this is the error that could have happened. The temperature is different than 45 degrees, but our sample did not give us convincing evidence that it was. That would be a type 2 error. So you got to think, all right, what would the error be? How could I have screwed this up? Okay, we would have screwed this up if the tank is actually different than 45, because we said we do not have convincing evidence of that. So we would screw this up if it was different. So if the second one is true and we screw it up, that is a type 2 error. I don't know, does that help at all, maybe? A little bit? Some? Hopefully. For me, that's how I'm keeping track of them right now, about which one is which. When do you raise the alpha level? I don't know if I want to answer that quite yet. It's in the Desmos. I'll tell you in a bit. I want other people to try it out. Raising the alpha does increase the power. Correct. Raising the alpha increases power. All right, ladies and gents, try out the last couple slides of the Desmos if you haven't clicked over there yet, okay? See how you're getting this. Again, not high stakes right now, so try it out. Can you figure out this error stuff? I know it's hard, but that just means we got to practice.